Hello everybody, welcome to today's class on AutoCAD Electrical. Today we're working on Module 7 and our topic is creating circuit for the power layout. It will involve sample circuit with electrical components and grouping components of the power layout into sub-circuit. What we're doing basically, it's like what we did for our other layouts, that's the luminary. What we did for our luminary by grouping it into sub-circuit, that's basically what we'll be doing for today's class. Okay, I'll take you to our AutoCAD environment where our design will be done basically. Okay, this is our power layout which we designed in our last class, that's the power layout. Today we'll be grouping the components here, the switch sockets into sub-circuit. Okay, for example, let's look at our living room. For our living room, we have a double ampere 13 ampere socket, double switch socket, and we also have a single 15 ampere switch outlet. Okay, what we'll be doing is that at the end, we'll be grouping all these into one circuit, a sub-circuit, and we'll be connecting into the MCB, Miniature Circuit Breaker. Okay, at the end, this is what we'll have now. We'll have this. This is the sub-circuit grouping. Starting from the living room, we're using letters to group them. So we have here S1, 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 S1. Also, we have for the foyer part of the building S1, and here we have the carport, the switch socket outlet here S1. Now, if you look at the living room very well, you find out the S1 are 1, 2, 3, 4, 5, 6 points for the S1. And here where we have a point here for the socket, point here for the AC, that's our air condition point for the living room. It's called the SB1. It has a circuit SB1. This implies that the 6 points for the S1 has a total load of 1 kilowatt, and it will be connected to a 5 ampere MC on the DB, that's a distribution point. Here the SB1, which is the AC point, we are using an AC of what, 4 kilowatt AC rating, hence it is connected to the MC of 20 ampere. Likewise, all parts of the building will have the arrangement thus. Here we have the dining room and the kitchen. The dining room has the S2 subset. 1, 2, 3, 4, 5. Now this part that we call it the S2 involves the dining room and the kitchen. Both 13 ampere socket point and 15 ampere socket point are connected to the S2, and here we have a cooker point, a cooker unit SB2, and here also we have SB1, which is the water pump. Okay, looking at it on the distribution here, we see that the S2 has a total load of 7 kilowatt, and that's a huge load, say about 7,000 watts. Hence, it is connected to a circuit breaker of 30 ampere on the DP. The reason why we are having up to 7,000 is because the kitchen here has power sockets here, whereby these sockets will take heavy duty appliances like the refrigerator, the water heater, and other powerful appliances. Okay, the SP1 goes to its own separate point on the GB. The SP1 goes to the 20 ampere MCB. The SB2, which is a cooker point, here we have a cooker point in the kitchen. The SB2, this, it takes its own point on the GB where it has 30 ampere MCB. Okay, likewise, all other parts of the building, for example, the S3 takes the family lawn, the study corner. We have the S4 takes the master bedroom and this other bedroom, both the master bedroom and the single bedroom. The S5 takes this point, the bedroom and the service room. Now these are all the subcircuit. Now looking at the rating, find that the S3 has a total load coming in, that the load coming into those points 1 kilowatt, and it is connected to a 5 ampere MCB. The S4 has a total load of 1 kilowatt and is also connected to a 5 ampere MCB. Now for the S5 here, you see it's also 1 kilowatt and is also connected to a 5 ampere MCB. Looking at the SB3, SB4, SB5 and SB6, you find out that the SB5 represents the heater, the water heater in toilet that heats up water for bathing. Now the SB5 has two toilet points here, 1, 2, and the SB6 also has 2 points, 1, 2. Hence, these two heaters are connected. For the SB5, the two heaters are connected to the 20 ampere MCB, and the SB6, the other two heaters, are connected to another 20 ampere MCB. For the SA1, SA1 represents all the AC points in all the rooms. SA1, SA1, see SA1 here. These are AC points, and the AC we are using has a rating of about 4 kilowatt. Hence the AC point will go to 20 ampere MCB each on the distribution board. Now that is how the sub-circuit operates. All the components are classified into different sub-circuits. Hence, when there's a fault in, let's assume, the master bedroom, there's some fault in the master bedroom. Master bedroom contains the S4 sub-circuit and it has 1 point SA1 and it also has the SB6. Hence, if there's a fault on these points, they put up the S4 socket point on the MCB, and they can work on this building, on this part of the building, without affecting the other part of the building. Okay, I'll go through the whole power layout sub-circuit, so we'll see how the sub-circuits are arranged. Okay, we have the SB1, S1 arrangement, and this is our living room, the terrace, our toilet, foyer, and the carport. Scroll down to see the other arrangement. The S2 arrangement takes the dining and the kitchen. Our S3 takes the lobby, the guest bedroom, and the family lawn, including the study corner. The S4 takes the lobby here, this bedroom, and the master bedroom. Okay, looking at the S5, it takes this bedroom, the service room, then our toilet, and the heaters for the toilet takes the SB5 and the SB6. Okay, we have come to the end of the sub-circuits for the power layout. At the end of today's class, you should be able to design a power layout and also group the components into sub-circuits. Thank you for joining us in today's class. I hope to see you in our next class.